So we're back and we're going to look at what I just did with the balloon and the aluminum ball, and roughly we're not going to actually analyze it perfectly. We're just going to sort of give you an idea of what's going on. Okay, so I have this concept, electric field. And so in my example, what I'm going to do is I'm going to say that I've got a ball that has a mass of 0.13 kilograms, and it has a charge of, let's say, 0.5 nanocoulombs, and there's something over here, and I don't really know what it is, but it's got to be negatively charged because the positive charge is being attracted to it, and I don't even really know what that distance is, so I know I've got some negative charges over here. Okay, well, if I look at the forces, I know that the force gravity is going to be 0.13 kilograms. I'm sorry, that's grams. 0.13 kilograms would be really, really high. So I'll throw in a times 10 to the negative third to make it kilograms, times 9.81 meters per second squared. So I know my force due to gravity is going to be 0.13 second EE, well, 0.13 second EE negative 3 times 9.81. It's going to be 1.28 times 10 to the negative third newtons. That's my force gravity. And I've got this electric force that's pointing this way, and I know that they're related through tangent theta. So I know that force electric is going to be force gravity times tangent of theta. So it's going to be 1.28 times 10 to the negative third newtons times tangent 10 degrees. So my force electric is, take my answer and multiply it by tangent of 10 degrees, and I get 2.25 times 10 to the negative fourth newtons. Okay. Now, the big equation that I'm going to do is I'm going to say that F equals EQ, where E is the electric field. Okay? And so I'm going to say my E is going to be F divided by Q, so it's going to be 2.25 times 10 to the negative fourth newtons divided by 5 times 10 to the negative 10th coulombs. So I'm going to divide that by 5 to the negative 10th coulombs, and I'm going to get 4.5 times 10 to the 5th newtons per coulomb. An electric field is going to be measured basically in newtons per coulomb, and those numbers for electric fields are going to be quite large. So the idea is that we're going to sort of quantify all of this charge and all of this distance and all of this gunk. We're going to sort of take a lot of complicated stuff going on under my left hand, and we're going to replace it by this simple idea, which is E which is just the electric field. So all of that stuff creates, at that point in time, an electric field that has a value of 4.5 times 10 to the 5th newtons per coulomb. Now, as long as I've got you, I want to just talk about how okay, very important. How do charged objects attract neutral objects? Okay, well, remember we have this F equals K Q1 Q2 over R squared. Okay, so basically what you're going to have is, suppose I have some charged object. Now, what I'm going to do is I'm going to put here some neutral object. Well, the neutral object has the exact same number of positive charges and negative charges, so you would think that it shouldn't be attracted at all. But everything is made out of electrons and protons, and electrons have charges and protons have charges, and things can move around a little bit. And so what's going to happen is that the electrons are repelled and protons are attracted. Not a whole lot, but a little bit, and just enough so that some of the electrons end up over here and some of the protons end up over here, and so now the protons are closer and electrons are further, and so what overall happens is the protons are attracted with more force. Because of this, because this R because R2 is greater than R1. So what I want you to do is okay, what I want you to do as a lab that anybody in the world can do is basically turn on the faucet so it's just dribbling the thinnest stream, not individual drops, but just the thinnest stream of water. Take a balloon, blow it up, tie it tight, and then rub it on your hair, assuming that your hair is clean and dry and not too oily, and then bring that balloon close to the stream of water and see what happens.